let's get started. Okay, now, again, Mr. H guy is going to do the complex ions chapter, and I will certainly assist him. And we may actually do a lab with that. We need the problem is we need a Spec 20. We really should have that, and we don't have it. But anyway, let's make a connection between periodicity and bonding, okay? And I think the biggest connection there is going to be electronegativity. We all know what electronegativity is. It's based on the bonding shell. For instance, fluorine bonds on the second shell. Bromine, excuse me?
Fluorine is the strongest.
Is the most electronegative, correct. But the bonding site for fluorine is shell 2, so it doesn't have a lot of, there's not a lot of shielding, is there? Between the nuclear charge and the bonding site. Whereas opposed to bromine, which is, the bonding site is what? 2, 3, 4, right? The fourth shell, 4p, correct? That's going to be more shielded, correct? Now, why is fluorine more electronegative, for instance, than francium or cesium? Down in the lower left-hand corner, because, or compare it to lithium. Because, yes?
It has a stronger nuclear attraction, like there isn't so many electrons around.
It has a stronger nuclear attraction, I like that. Relative to lithium, it has a stronger nuclear attraction, so there's a connection between atomic radius, isn't there, and electronegativity in a sense, correct? So if you have to analyze it, that's also true, right, Ling Ling? You're yawning, I saw that yawn. That's okay, I forgive you. It is early in the morning. So, but what's the other big thing? And I don't want to use that number between 7 and 9. I don't want to use that as an excuse. Why is fluorine more electronegative than, so there's several reasons. There's the nuclear charge mainly, right, for so far, and it's not shielded. Yes, Lauren?
It's also, it also decreases down a group. It increases from left.
No, you're giving rules that explain it. I want to know why.
Oh,
I don't want to know patterns. I want the W word. Why? Yes.
Because the more electrons there are, the more that they repel.
How? All right. Let me lead you. Let me lead the witness.
Okay.
Let me lead the witness. What is what is fluorine's proximity to the nearest noble gas?
It only has to gain an electron.
It only has to gain an electron. It's right there, dude. It's right there, right? So that's big. I don't like to use that number between 7 and 9 as an excuse. That's like, we don't say Voldemort, right? Right? We don't say that number between 7 and 9. Okay? Because that's too easy. It's too easy. It's really, you got to think, it's the noble gas. You see, everything on the periodic table is relative, isn't it? We don't know what stability is unless we see what the most stable is and the least stable is, correct? Yes or no? Well, the most stable is helium. It's the noble gas, correct? Yes? Argon's stable. That whole column is very stable. Well, why is it stable? Well, all right, you could say, well, it has a magic number between 7 and 9, but helium doesn't. So we just say that that's stable. We don't know why that's stable. We don't know why that magic number is so magical. We don't, really. We don't know. But it's a noble gas. So why is fluorine so electronegative? Well, the reason is because it's inches away from the nearest noble gas. So it really wants that electron. I mean, it really wants it. It's crazy. If fluorine was human, it would be in supermax prison. It's just a little nuts. It would be. It would be. Fluorine would be incarcerated for life, multiple life terms. It's crazy, very unstable. And it's very close to being a noble gas, and it's a wannabe. It's a wannabe noble gas, and it just isn't, and it just goes crazy to be that way. Do you get it? And that's electronegativity, really. So you can write an essay on your IB exam about fluorine and supermax prisons in the United States and see what happens. It'd be interesting, wouldn't it? Yeah, write a little story, you know, fluorine the convict. Yes?
Are the elements following fluorine more or less unstable?
Fluorine down to bromine, right? Iodine, they would be a little more stable. Why would they be a little more stable? Why? Not because of the proximity to the noble gas. That's the same, isn't it? But what's different? What's the variable? What's varying? As you go from fluorine down to iodine, what's varying? Not the proximity to the noble gas, that's all the same.
But they're gaining more electrons and protons?
No, they're gaining the same amount, really.
Yeah.
In terms of ground state, you go from fluorine to chlorine, you go from 9 to 17. You're gaining what? 8 protons and 8 electrons, right? Correct? But it's still only 1 electron away from the nearest noble gas, correct? Right? Okay, but what's different? The nuclear charge is increasing, so that's not it though, is it? It's the SE. The SE. What's the SE? What's the SE? Go ahead, say it, Porcia. Shielding effect. Yeah, you had it. You had the idea. It's a shielding effect. So that's why it's less stable, because that bonding site, we're going to call it the bonding site, is less stable. Is shielded. It doesn't have that nuclear charge. Is kind of a little wasted, isn't it? Yeah, it's a little wasted. Look at the ionization energy. So pull that into it. Come up with an argument. I like Lauren's questions because what that creates for you is a question. Now, Johnny Gunn, you have to write that question down, and what I want you to do, and everyone else, is write an essay. That's what this is all about, isn't it? No, you're not going to hand this in. This is for your own use. But you're going to pull together the reasons in your own words. Go research it. It's a research topic. You're going to research this and say, well, write down Lauren's questions. You have them on tape. And substantiate them. Bring in ionization energies. Defend yourself. Right? You have a client on trial. And you have to come up with a defense. You have to come up with this analytical, logical defense based on pure forensics. What's forensics means? What's forensics mean? Yes?
It's the chemicals left behind at the scene of the crime?
No. Because you have forensics accounting as well.
Oh.
There's chemicals involved in forensics accounting. You're right. I mean, you got the idea, but I don't think anybody ever told you what the word forensics means. You're just coming up with the word forensics based on television shows, and that's okay. Your answer isn't wrong. It is incomplete. There's a difference, correct?
Yes.
2 plus 2 equals 2. Well, that's wrong. Sorry, guys. But so what's the, finish the answer, somebody. Like forensics accounting. What are they going to use those chemicals to do? What are they going to use those chemicals to do? It's going to be what?
Find out what happened.
Right, it starts with an E. What's the E word we're looking for?
Exam.
No? When you go to trial, you're going to use it as?
Evidence.
Evidence. Good, evidence. So forensics accounting, what's that going to be? That's going to be the E word. Evidence. Right? So what do you think forensics is? It's simply evidence. That's all it is. It's evidence. It's support material. So you could say, this is still working, right?
Yeah, I think so.
You could easily say, all right, you're going to write a paper and I want your forensics. Your supporting material. Forensics really is used when you're talking about adjudication. What's adjudication? What does that mean? Something that goes in front of a judge in a court. Okay? When you talk about forensics, it's really it's adjudication. But you could use it anywhere. What's your evidence? I mean, you could misuse it. Let's create another usage for the word forensics. And the word forensics is just evidence. So where are your forensics notes instead of footnotes? What is your evidence in your paper, your support material? Yes? So you want to write a forensics essay to support and answer her questions. That would be a great activity. Look, guys, don't you want 7s? Or do you come in here to get 4s and 5s? Is that what your goal is? Okay. How many people in here want to get a 4? Raise your hand. Okay. How many people in here want to get a 5? Raise your hand. Okay, good. You raising your hand?
Well, I'm going like.
You're going to be happy with one. But how many people are shooting for a 5? How many people are shooting for 7s? Raise your hand. Come on, guys. All right. Get those. Yes, everybody. Monka, you're not shooting for a 7? Okay. Right, fine. He put up one finger, so that's like, you put up this finger. I'm not sure what that means, okay. But, so, earn it, man. I mean, you got to do some work. I don't want to waste your time, but you're the one that is going to be sitting on this exam with these essay questions. You got to try to figure out what they want. And the more you go through this stuff, the more sense it's going to make. Correct? So let's talk a little bit. Should we say that this is intro to bonding? And cut it because it's getting too long? Is that okay? Intro to bonding part 1. Okay? All right.